Hello, everyone. My name is Laura Fletcher. I serve as the Director of Marketing and Communications for the Eberly College of Arts and Sciences. It's my pleasure to welcome everyone to today's event. We're happy to have Dr. Jeanne Fair here. The name of the event is Transdisciplinary Research, Transformational Learning, and Transformative Science. So because we're getting started just a few minutes late, I just want to give a little bit of housekeeping and then start our event. So the one thing I want to mention is that we will have a Q&A at the end of the event. You can go ahead and put your questions into the Q&A box at any time. If you have any technical issues, I'm going to turn on the raise your hand feature. Please use that if you have any issues. Otherwise, we will go ahead and try to get to everyone's questions at the end of the presentation. In addition, at 1 o'clock, although our presentation will wrap up, we will have an extra 10 to 15 minutes as sort of a informal gathering with Dr. Jeanne Fair. So if you would like to stick around, please go ahead and do so. And we will go ahead and let everybody turn their video on and just ask her some other questions and have some one-on-one discussions. With that, it's my pleasure at this point to actually introduce our dean, Dr. Gregory Dunaway, who will get us started.
Well, good afternoon, everyone, unless you're in New Mexico, and then good morning to our honored speaker, Jeanne Fair, from Los Alamos National Laboratory. Delighted to welcome you all today to the second installment of our Transdisciplinary Research Colloquium. Colloquium is really the brainchild of Lupe Davidson, so I'd like to thank her for her efforts in coordinating this event. And I'd also like to also acknowledge and show my appreciation for the co-sponsors of today's event, our Center for Service Learning, our Center for the Humanities, and our Center for Resilient Communities. All three of these partner with the Eberly College in promoting and sponsoring this event. If you are a return attendee, welcome. If you're a new comer to this event, you're especially welcome. We just want to let you know that the college is very much committed to beginning a dialogue on transdisciplinary research and work and implications. We feel that increasingly this will be the future of our research inquiries and have a huge impact in terms of the impact of our creation of knowledge in communities, and also have implications for the way we teach our students. So with that, it's my pleasure to introduce Melanie Page, who is our Associate Vice President for Research and also Professor of Psychology, and she will introduce today's speaker. Thank you all again for being here.
Thanks, Greg. We're very excited to be part of this project. The research office is very interested in interdisciplinary and transdisciplinary research, and so we're really excited to be part of this project, and thank Dr. Davidson for inviting the research office in. I'm pleased. Hang on one second. I have to start my video. There we go. Because you guys haven't seen enough of me lately. Dr. Jeanne Fair is a scientist and deputy group leader for biosecurity and public health at Los Alamos National Laboratory, with a focus in epidemiology and animal disease ecology. Fair is the principal investigator for a 23-year research project on the effects of environmental stress on avian populations and infectious diseases. In 2009, Fair was the lead analyst for the Department of Homeland Security's modeling of the H1N1 influenza pandemic at nation's critical infrastructure. From 2013 to 2016, she was on assignment as a science program manager with the Cooperative Biological Engagement Program for the Defense Threat Reduction Agency, working with Central Asia and the Middle East. We are extremely excited to welcome Dr. Fair to campus virtually, and are really excited to hear her talk. Laura has put in the chat how to access the slides. So if you need to access her slides, please do that through the chat, and make sure to put your questions in the Q&A. I'm going to turn it over to Dr. Fair. Welcome.
All right, well, good afternoon. It's afternoon there. everybody. Let me share my screen now. Make sure that works. All right, so how does that, how do the slides look for you? Is that a full screen?
Yep, looks good.
Okay, perfect. Well, thank you so much for inviting me. I was really excited about this, this topic and this initiative about transdisciplinary research at your university, because for me, I think right now it's more exciting than my actual science in ornithology and infectious disease and actually, believe it or not, preparing for pandemics. So today I'm going to give a story. I'm going to tell a story that happened in New Mexico back in 1993. And this story is a great story about transformative science and how do we get from just multidisciplinary to transdisciplinary to actually transformative science, and how do we do that through collaboration. So that is, there we go. I want to make sure, there we go. So when we think about transformative science, it's really about research that's driven by ideas that radically move us forward, not just in one field, but in potentially many fields. And so it may lead to a new paradigm or a shift in paradigm, or actually lead to a new field of science or engineering. The way I'm going to tell my story today is through 4 leading areas of thinking. So first we have our scientific questions, then we might have unexpected answers, then we have this collaboration that's across scientific disciplines, and then we have the transformative part of that science. And so I'm going to tell the story with these 4 sort of sort of the way the story unfolds in different pieces. This story is coming where I'm at in New Mexico. We often call it the land of the flea and the home of the plague. So plague is very common here, as well as tularemia, as many zoonotic diseases that are in the West are all found in New Mexico. So the story begins actually April. So in the spring of 1993, so same April right now, we're in the windy season I've talked about. So April 1993, there was a 24-year-old American Indian that arrived into the emergency room in Gallup, New Mexico. It was the Indian Services Hospital. She complained of flu-like symptoms and a shortness of breath. She actually died later that day, soon after her arrival. So the family was distraught, but 3 days later, they were heading to the funeral, and her 19-year-old boyfriend on the way to the funeral became severely short of breath. Instead of going to the funeral, he went to the hospital, which essentially was across the street actually, and he then died upon arrival at the emergency room. So if we look at these 2 cases, these are the boyfriend and the girlfriend. This was what their lungs looked like when they first showed up into the emergency room. And so they were starting to fill up with liquid, but here's what they looked like just 2 to 3 hours later. And so we could see that this whatever was killing them was killing them very rapidly, within hours of when they got there. So Bruce Tempest, he was the doctor, the internist there in Gallup, and he was the one that was admitting them both. And he was particularly struck by the boy's age of 19 and his athleticism. Something didn't seem in order. And so he did remember some colleagues that were discussing a similar case, a few cases actually in New Mexico. And so he thought, well, maybe there's a connection between these 2 victims and these other cases. And so he asked that question. And so the first thing he asked himself was, first, is there a pattern? And so by then, later that day, just within 24 hours and a few phone calls, he actually compiled a list of 5 similar cases. So that was his answer to that very first question. And so then they brought in clinicians and the public health officials. So now they brought in the state of New Mexico Public Health, and that included the director of infectious diseases at that time, Dr. Gary Simpson. He was brought in. And so they wanted to figure out, okay, we think this really is an infection. Well, what could it be? And this was the first time, at that time, it was sort of the biggest, almost immediate response with bringing together different people into the room that included the forensic pathologists and the doctors in the region and the Department of Health for New Mexico. So then New Mexico then said, okay, let's put our laboratories into motion. They wanted to look at the autopsy samples. They looked at the medical charts. And at that time, we did have an extraordinary plague laboratory because plague was particularly common here, transmitted by fleas in rodents and other small mammals. And so they thought, well, maybe that's what they're dealing with is pneumonic plague. But they couldn't find any bacteria, no plague bacteria, and no tularemia bacteria that were found in the victim's blood or their samples. So then they asked themselves the question of, well, what is causing this disease? If it's not what we're usually used to here in New Mexico. And then they said, oh, well, let's see. We can also look for some viruses. So they looked for influenza and the answer was no. And then they looked at herbicides. Maybe it was a exposure to some sort of toxicant, and the answer was no. And so they brought in even more people to their fold. And so at this time, it was 1993, and polymerase chain reaction, or PCR, was literally just invented, really. And this was the first opportunity for the world, essentially, to be able to look at the genetic makeup of an organism, whether that's a virus or a bacteria or a human or a skunk. So they were able to take that molecular PCR technique and apply it. And so this was the first time that PCR was ever used in a investigation of an outbreak. And so now all these years later, we can look at how far we've come since 1993 with our current pandemic, just as a way of thinking of the relevance of this. So again, this was the first time that molecular biologists were brought into the fold to be able to be on the front line of an outbreak investigation. So now the virologists could actually link the pulmonary syndrome into a previously unknown in North America hantavirus. So they knew hantaviruses were transmitted to people from rodents, and most of that was from the Korean War. So a lot of our soldiers in the US came back from the Korea War in the 50s with hantavirus, and they got it there. So hantavirus were not unknown, they were just unknown here in the United States. And so then they said, okay, well, we know it's by rodents, and so let's go out and trap the rodents. Now here's what the team, that I worked a lot with this whole team with telling their story, and one of the things they always want to point out is that it was really fortuitous that this happened, because Gary Simpson, who was the director of infectious diseases for the state, happened to live next door to a professor named Terry Yates. And Terry Yates was the director of the Museum of Southwest Biology at the time at the University of New Mexico in Albuquerque. And he happened to be a mammologist, a small mammal mammologist. And so they were talking about this, and he said, well, I have, actually we catch rodents all the time, is what we do. And then also I have a museum with tens of thousands of small mammal samples going back decades. And so they always point out that don't forget to tell that it was this fortuitous event that they happened to be neighbors and to be able to talk. Now, so once they found this, the CDC then came out, and the CDC also began an investigation working with the Department of Health. And usually when you name a virus, you name it around the area that it might have been found. And so where it was located first. And so in this area around the Gallup and between Gallup and Farmington, where there was a canyon called Muerto Canyon, which is basically Death Canyon. And so the CDC wanted to name it that, but then the Navajo community in the region said, no, you can't name it that. And then the Forest Service was like, no, you can't name it that. And so they changed their mind, but they couldn't come up with a name. And so they called it Sin Nombre, which is no name. And so literally Sin Nombre hantavirus is no name virus. So they now knew that it was transmitted in deer mice. And so they were starting with the trapping, and they were starting to see that it was found in the deer mice. And so we never want to forget that it was all started with the mouse. And just to quickly go through the transmission of hantavirus, so we have this chronically infected rodent, and then in certain years they'll have exposure to the virus, and they're shedding it, through their feces and through their urine. But the team didn't quite know that at that point. They didn't quite know how it was being transmitted. But then it's aerosolized in the, particularly urine actually. But again, how are you exposed to, deer mice urine in your house? And so they knew that this from the studies in Korea and other areas. So now they said, okay, well, we know it's hantavirus, we know it's in small mammals and deer mice, but how is it being transmitted to humans in this region? And so the answer was that they found out that, and just through the whole collaboration, that they were breathing this contaminated dust into their lungs. And in particular, in these two households where the first two cases were, they found that they were sweeping up in there. In one case, there was even a woman in that same time period that was vacuuming. And so she was vacuuming her house where there had been some mice droppings, and that aerosolized it. And of course, now with coronavirus, we're all familiar with how aerosolized viruses work, but it's the same way with the hantavirus. And so, but to do this, so the collaboration, they brought in aerosol scientists. So now they needed a whole different set of skill sets. They also brought in the ecologists to sort of, work with the mammalogists and look at the areas around outside of these areas, and then the epidemiologists. So they kept building on this team. Now, this has been a very short time period. The time period of this story is really actually less than a month overall. And so now we've gone to why the heck are these people dying, these young, healthy people, and then having more cases, to now we know what this unknown virus is. We know it's transmitted by the small mammals. We know they're getting it probably by sweeping and the aerosolizing of the virus. And so that was then sort of the transdisciplinary or the transformative part of this, was just that, how you could get exposed to this. They really needed the aerosol scientists to be part of this team and to understand these mechanistic, how the virus was transmitted, to be able to come up with the mitigations to stop it. So overall, in 1993, the Sin Nombre strain of the hantavirus killed 27 young, otherwise healthy people. And they found out that year that 30% of the mice in the whole Four Corners region in the Southwest were carrying the virus. But they themselves were not sick or dying. So they were like, well, why still did this happen? And so the humans, they obviously had this increase of their contact, but why had they never seen this before? So this led to a whole nother set of questions. So what was different about 1993, that the mice were suddenly infected with the people giving them the virus, and that they were then dying from it? So this next question then led to, well, what was different about 1993 is, can we show something in the environment? Can we look at climate? And so they started to bring in meteorologists now. And they could see that the El Nino weather patterns were different in 1993, other than, different from other years. And so then the collaboration then that they brought in, and now on top of this whole team, they brought the climatologists, they brought evolutionary biologists, and they brought more of the environmental scientists. And then they could look at then this episodic nature. And so they could see that year before was was an El Nino and that there was a particularly high amount of rain in the region for New Mexico. And that led to larger mouse populations. That led to a bigger seed set. And so the mice populations had a lot of food, and so they increased. And so then that led then to the hantavirus outbreak of that year. But now the transformative part is that weather is now used as a significant predictor of disease. So much so that after this event in 1993, all of these people stayed in contact, and I'll talk a little bit about that. But they stayed in contact and they started looking at the weather patterns and knowing, okay, next year is going to be an El Nino or an El Nina and what that meant. And they started then informing the public, saying, okay, this next year is potentially going to be high for hantavirus. And so you need to take care with your sweeping out like an old cabin or an RV you haven't used at, wear a mask or wet it down with Lysol or water. And so they started doing a lot of more public communications about it. But they could predict then into the future, is next year going to be a big hantavirus year or not? So going back to the case study and that that this basically went from, like I said, pretty much under a month. And then the last few weeks of that was on the climate part and bringing in what made this year different. And it was really based on the collaboration between all of these, not only agencies, but the individuals that were investigating this outbreak from the core team. And that time in 1993, they had a lot of public interest, of course, in this. And so there was, in those initial 2 weeks, there was, daily press conferences. And so they had to make sure that they were in communication with each other, but that everybody was sort of on the same page on what they were communicating. And they created a consortium for themselves. One of the things with this consortium, they ended up calling it RAMBO, which stands for sort of medical research. And it's a consortium that still lasts to this day. Not as strong as it did for about 12 years after this. And I'll talk a little bit more about RAMBO. But one of the other things that came from this work is New Mexico is actually I think it's the only state where necropsies of febrile illnesses related to death, so knowing it's an infection, are mandatory. And to think about that, that's actually remarkable for our state because a vast population, a large population of the state is Native American. And so at that time, that was one of the challenges that the team had to work through. One of the things is that if somebody has passed, you don't talk about them. You don't talk about why they died. And so now you're trying to do an investigation to figure out exactly why that and to talk about it. And so the Native Americans had to have a lot, in particular this region was the Navajo, had to gain a lot of trust with the team. And this includes this state mandate for necropsies. And so they understood from going through this so many years ago, the benefits of this, that it saves lives in the long run. And so that's just one sort of phenomenal policy that came from this science. So again, we go from divergent thinking to transformative science. And so it's across disciplines, right? And so multidisciplinary is very difficult because we all have different jargon and language, and actually the same word maybe means something completely different in one field from another. And if researchers don't believe that the benefits are high for themselves in a collaboration, then they may not choose to invest their efforts in that collaboration. One of the things that this team points out is that because people were dying, and so similar to the pandemic now happening with the coronavirus, that led to more of an interest to collaborate because there was this really important and unknown challenge that they were faced with. And so that was sort of one of the key things that was helped drive the collaboration itself. as well as right now with the pandemic. You know, I think it's something like 2,000 publications are published every day on coronavirus in some way. And the National Academy of Sciences has a study to just figure out how do you wrap your arms around that much scientific output actually in such a short period of time. But it's the same thing, as we can all see the effects of this pandemic that we're now living in. And we can think back to this small team in 1993 and think, you know, they found out what this was, and it didn't even really become, you know, an outbreak over the whole state. They really contained it by applying what they were learning. So transdisciplinary teams, it's really this, what I was just trying to talk about, which is really this volatile, sort of uncertain, complex, and ambiguous. I mean, does that sound like 2020? All of those things. I mean, you put 2020 behind them, and now 2021. But that really does help with this sort of transdisciplinary research, but then making it transformative, because people are operating in such an uncertain time. And so they're really having to focus on both the collaboration, not just what they're doing, but what can we put these pieces together. Gary Simpson, the director of infectious diseases, became over the years a really close friend of mine. And one of the things that he would say was that if you're exchanging a business card on the first day of an outbreak, then the pathogen's already won. And so part of what they learned was that, you know, continuing these relationships and continuing to know each other and reach out and to build networks really does help us when that day comes, when there really is an outbreak. So the story that I'm telling here, we talked about in a paper that was in Bioscience a few years back in 2013. And this was where we lay out sort of what happened and how does this apply to transformative science now, and what can we learn from this lesson, from this phenomenal group of people. And so we can think of transformative research teams. And so they have a shared commitment, right? There's a shared commitment to finding a solution. In this case, why are these people dying and how can we stop it? There's a deep knowledge within the different fields of expertise. And even though PCR was new, you know, the people that were starting to do it, it became their expertise very quickly. There was this shared ethical and moral value system that was between all the collaborative engagement. And so when I talked about the public affairs piece, you know, within the team, what do they want to share and what do they not want to share yet? Are they on the same page? And that was just really through constant communication and being very transparent. It was this connections between these networks of knowledge as well. And so again, the fortuitous aspect was important here, and they do point that out, but a lot of that is being open to relationships in other fields and potentially your neighbor. And that their institutional access at that time, because it was an important thing, gave the materials and you know, helped fund some of the experiments. And then this team literally went on for 25 years to do the majority of work on hantaviruses in the Southwest. And so many studies, primarily at the University of New Mexico, but they continued working together on all of these, you know, NIH and NSF proposals and then projects over the years. So in this paper, we had this sort of idea. I talked about Terry Yates, and Terry Yates, you may think, well, he wasn't like one of the primary physicians, but he was this phenomenal character that was, you know, headed up the Museum of Southwest Biology, and then later become VPR, so Vice President for Research for UNM. But he was just one of these characters that brought people together and then was open and communicative, and everything that you think of as a leader, he sort of had that, but primarily with wanting to bring people together. And so this, we call as this Yatesian zone. And so, you have your knowledge of other disciplines. And so he had this broad knowledge of other disciplines as well. But then he also had this very specific skill set of understanding, small mammal populations in the Southwest. And so he had sort of this mutualism and this integration, and that's where this sort of synthesis takes place on these multidisciplinary teams. And that's where you get transformative learning, and then in the end with science, potentially transformative science. And so there was a lot of first in this. So it was the first time that molecular biology PCR was used in an outbreak investigation ever. And it was used to actually identify the causative agent. It was the first instance where forensic pathologists really did play a role in the detection and investigation, and then bringing in actual researchers and scientists and more academics in the, right from the beginning. It was the first time that evolutionary biology was actually used to anticipate then, is this going to be, what is it going to be like in 2 years or, farther out? And is the virus changing with the dynamics of the small mammal population? And so there was a lot of first in this team. So here's what the community they created, which is the Research Association for Medical and Biological Organisms, RAMBO. They love the name RAMBO. And then was Bruce Tempest, so he was the initiating doctor. Brian Helley, who became a hantavirus, he was an infectious disease researcher at UNM. Then Terry Yates. Terry Yates, unfortunately, died of brain cancer in 2007. And we had Robert Baker. Robert Baker was also a bat and small mammal researcher from Texas Tech, actually. And so he was also brought into the fold to start understanding that ecology between the small mammals and the viruses. And then, of course, we had Gary Simpson. And then we had many more over the years. So this group grew into a community that would meet regularly. They would meet once a month. They had potlucks at one of their houses, and somebody would give a talk, or they would do things together. And it was really about that community that they shared. They became, best men in each other's weddings and became very close. And then that led to just a phenomenal amount of research over the years. So now you think of science of, the science of team science. It's a new field roughly in, the last 10 years, maybe 15 years. And there's a professor at Arizona State, Barry Bozeman, and he has done quite a bit in this field of understanding research collaborations. And he has this idea, like, we all say, okay, if you think back of collaborations, that was a good one, or, we can always think of like, oh, that wasn't so good, that was a bad one, or maybe even a nightmare one where somebody ends up in court. But mostly, there was good. We had some good science, we got some publications, we liked each other. But how do you move that into the dream collaborations? And that's sort of where this transformative science takes place. And so how do we keep moving the bar to the right? So we have these really great collaborations we have now, but how do we move them into dream collaborations where not only that we're doing good science, but we are enjoying each other and enjoying the work even more. So Barry Bozeman, Dr. Bozeman likes to apply this Tolstoy principle of research collaborations, which traditionally the Tolstoy principle of families is that all happy collaborations are like, each unhappy collaboration is unhappy in its own way. And so the opposite of that is all happy collaborations are like, but collaborators themselves are all made happy. They're not made happy in the same way. So we all have different things of why we enjoy our colleagues. And so it might be that, if you are more of an extrovert, you may really enjoy in-person meetings and love getting together and going to the whiteboard. But as opposed to if you are more of an introvert, that may not be your thing. But we've all had to know what it's like to be on Zoom now. And so how has that changed us? The story for that is not written yet. But everybody's a little bit different, and that's okay. But understanding those differences is really important. And so Dr. Bozeman when he thinks about collaboration, he has several different types of collaboration. And there's, one of the type that he's trying to get everybody to go towards is what he calls consultative collaboration management. And so give you an example of one of the types of collaboration management is dictatorial, right? So it's sort of like management styles. So we don't necessarily want to be in a dictatorial collaboration. I mean, they work, but not as well as this consultative. So when we have this type of collaboration, we're moving the bar to a dream team. And so the first thing is we have sufficient communication structures, and we understand how everybody likes to communicate. So knowing, especially if you have a small team, but knowing, does my colleague like to be emailed, or does he like me to just call him up or meet over coffee? Like sort of knowing how other people best communicate can be really important. But then you also have these whole team communications rather than just subgroups. And that sort of leads to this transparency. And all of these things are leading to the third, which is this high level of trust. Now, there's been some papers out there that have showed, looking at collaborations and measuring the level of trust and then the outcomes and saying, okay, they didn't find a correlation between trust and the outcomes of research projects. But I think that's really short-sighted in that because some of these papers say, well, therefore it's not important. But what they're missing is that even when trust is not there and bad things happen and your collaborator writes a paper without your name on it or whatever, that because it's science in our job, we still do it, we still get it done, we still turn in the deliverable because it's so important to us, we move it forward, but it keeps it in that sort of good collaboration, maybe poor collaboration. It doesn't move it to the dream team. And so a high level of trust. The next thing is just sort of this sort of a non-existent association between the assessment of these ideas and the individual, presenting them, and that there's an open-mindedness and that a respect for other colleagues' ideas for this. And with the initial team of the hantavirus, just from the beginning, there was a tremendous amount of respect because they really need each other. And so again, having it because it was this volatile, sort of, uncertain challenge they were facing, they realized they really needed each other. And so with that came that respect and openness. The fifth thing is this commitment to this open and transparent disagreement. Our disagreement is part of science. It's how we move forward. And so they were all open to that and brainstorming because nobody had the idea. And so disagreement was validated and heard, and then went through to see if something was true or not. And that you can revisit these points in the disagreement and then have new plans of action. And so again, keep asking questions, keep getting answers, keep asking questions, keep getting answers. There was a recognition at that time in 1993 for the diverse values of everybody involved. It was a diverse team in New Mexico itself, but they were also dealing with the Native Americans. And so being extremely sensitive to what that meant and how they can move forward and figuring out what was killing the people, with being sensitive to the differences in the community there, but also within their team. So now it's a multi-agency team. And so you have, the CDC sort of came in for a while, but it was really New Mexico that's, said, okay, well, I'm with the Department of Health, but you're at the university and you're with the local hospital there in Gallup. But really saying that all of that is fine and that we're all in this together. Now this slide is actually one that I've thrown in. So if you're following along, you won't see this slide, but if you can see him on the screen, you will. And I just wanted to point out that in the last 20 years, there's a lot of people saying that we're in a research collaboration revolution in itself. That's not, science, how we do science necessarily hasn't changed with hypothesis testing and statistics, but there's been an increase in the number of collaborations and the number of teams for collaboration. There's sort of a commercialization more of, particularly in academics research. We're solving bigger problems, but some of those problems have economic rewards. There's a lot more gender diversity in science. There's multiculturalism and a lot more international collaborations, but that is sort of leading into maybe bigger problems with teams. So contributorship or authorships on publications, and then we have an increase in ethical issues potentially across the board. And then now there's this sort of self-consciousness about team science policies, and then how can we manage the collaboration? So if the teams are larger now, do you actually need managers to manage it? And so all these things are sort of coming up as part of this revolution. I will point out on the right lower corner, this is a team. We're standing actually on top of a mountain in Kazakhstan. And the middle man in the blue jacket is Linfa Wang. And Linfa Wang is a professor of infectious diseases at Duke University in Singapore. And he's basically the man that is linked many years ago when the first SARS outbreak happened to be able to link coronaviruses to bats. And so he's essentially the world leader for coronaviruses. And he discovered the Hendra virus that was found in horses across that region. And so this was actually to do a bat training to teach people, and particularly this was in Kazakhstan, how to look for coronaviruses in bats and other animals, including camels. Largest number of authors on a scientific publication is 5,154. And so with that, with this paper, it was with the Higgs Boston. I think it was 24 pages was the actual paper, and then the authors took up 36 pages. So hopefully we'll never be part of like collaborations this big. But they did the alphabetical. So the primary author, his last name is And, A-A-N, A-A-D, Ad. So, and then again, scientific collaborations are increasing. And that was one of the reasons why I got so interested in this topic, because as a program manager with the Department of Defense, my job was to create scientific collaborations and bring people from our partner countries like Kazakhstan or the Middle East and Jordan and Iraq and Afghanistan and Southeast Asia, and bring them together with US or European collaborators to increase their surveillance capabilities for especially dangerous pathogens and pathogens of pandemic potential, such as coronaviruses. And so how do we bring these people together and make them sustainable collaborations? And so I've been fortunate to have just dozens of collaborations over 30 years, and I've had most of them have been right in the good. I don't think about any, I've had no nightmare collaborations. I don't think I've really even had a bad one. They've all been right in that really good area. Maybe a few you could call a dream team, but everyone is enjoyable. And when we get to thinking, when we ever meet anybody, there are three things that we ask ourselves about them, and they're asking themselves about us. And the first question is, do you care about me? And the second question is, how will this benefit me? And the third and most important question is, can I trust you? And when we think of trust is really three things. It's competency, so skill set and being really competent at your work, and then there's character, which is your integrity. Are you going to say what you're going to do, or do you do what you're going to say? And are you open communicator? And then the third piece is compassion. And so those are the three things that make up trust. So it's not just trust is a single dimension, it's actually many things. But the way the other way to think about it is to ask ourselves then, well, am I effectively communicating that I care about you? And how am I benefiting you in the team? And the third question is, well, can you trust me? And so those are sort of how to flip it to make sure we're bringing the best that we can to collaborations, and that we can move them, the potential of it and the potential of science and research can be so much greater if we're just more cognizant about these things. And then also just that we enjoy ourselves so much more. Yeah, I interviewed many scientists with a few questions just this last year about what they think makes a good collaboration. And one of the best quotes was, well, I never want to collaborate with somebody I wouldn't have over for dinner and a beer. And to move away from any sort of toxic workplace in our collaborations. And I'm going to leave it here with a quote by Laurie Garrett. Many of you might have know who Laurie Garrett is now because she's been on NBC throughout this pandemic, and she wrote The Coming Plague. But we always want to believe that history happened, only to them, and it was in the past, but somehow we're outside of that history, rather enmeshed within it. And so I think the timing for telling the story right now is also good, because the pandemic is not only changing us in every science about how we work together and communicate and collaborate, but it's also changing how we think about outbreaks, and how to communicate that. And then also, how do we now work with misinformation, which is sort of the next challenge. So how do we work through that as scientists? And I will leave it with that. And I have time for questions, I believe.
Thank you, Dr. Fair, for that very interesting talk. Interesting, when you're talking about this sort of small world idea, right? And the two people were neighbors. When you started talking about the case, I was in Arizona in 1993 and remember the fearfulness of, right, not knowing what's going on, what's causing this, and the actual relief when it was deer mice, right? Like if you're in the city, you're like, okay, well, right. But it actually, that actually led to us having a supply of N95 masks in our house pre-pandemic, because we never do anything in the basement or where mice could be without an N95, because of that experience. So that's kind of interesting.
Yeah, that's right.
We have a question kind of related to, you had talked about working with the Native American tribes. And so this question kind of deals with that. Can you go into more specificity about the importance of considering non-scientific ways of knowing, especially given the importance of inclusion of Native Americans in the Hantavirus challenge?
Yeah, that's a great question. And something I didn't actually touch on, but the team went back and actually talked to the elders in this community, and the Navajo elders. And they found out that in 1918, there was a die-off in their communities. Now influenza was extremely, well, there was a 1918 pandemic influenza. And so where I live, I actually live right next to a Pueblo reservation. And here they're called Pueblos. And in 1918, they had a 90% mortality rate from influenza. And so that's one of those things where different populations are affected so differently, and something that we feared with coronavirus, that there may be, and we did find actually that too, the Navajo population was hit very hard with the coronavirus early on last year here in New Mexico. They had a higher death rate. They also found they had a die-off in the 1930s and then later in the late 40s, 1948. And so from that, they could see, okay, this is a regular occurrence. And that little piece of meeting with the elders was really important for going, okay, well, what was different about those 3 years climatically? And looking back on the weather data that had been collected. And that's where they could say, oh, it was the El Nino years, was right before that. And so they knew there was a big seed set with pinyon and other things, and that the mice populations would be large the next year. And so they could compare that with the mice population they had as well. So that was one of the things that was really important. And then they were very sensitive to, again, communicating regularly with the Navajo community, who shut them out essentially to begin with, because they were like, well, we don't know what's happening and we don't trust you. And so they had to quickly build that trust. And again, the first piece was like, you know, being able to talk about one that's passed. I mean, that was very forbidden to their community and their culture, was you don't talk about them for a certain amount of time. And here the Department of Health, and it was saying, oh, we want to talk about it, like what, you know, and so they were very sensitive to that and worked with them to communicate why, you know, start with the why. Why is this important? And that really helped. Yeah, it's a good question.
Well, and that's a sort of interesting point when you talk about when cultural beliefs run up against the need for information, right, for the larger public health, and sort of whose needs get to win out. And I think we're starting to see that play out in this pandemic as well. One of the things that you were talking about that kind of interested me was, particularly from the research office, was this idea in your sort of time working internationally, and this idea of building these international collaborations with people who could be scientific allies, but are sometimes portrayed as political enemies to the United States, and this idea of foreign influence, and how do we balance science and this, right, taking advantage of everybody's brain power across the entire world, and this focus on keeping our stuff in America. So if you could maybe talk about that a little bit from your experience.
Yeah, no, and I'll tell you a little bit about how this program started too, because it's sort of an important piece, is that when the former Soviet Union fell in the 90s, they realized there's two congressmen, Nunn and Lugar, and they were across the aisle from each other, and they said, this is a big problem, because across all of these new caucuses, so think of Uzbekistan and Kazakhstan and Armenia and Georgia and Ukraine, is all of these weapons, nuclear, chemical, and biological, that are unsecured. They're all over the place, and they're not consolidated. And so they wanted to work with these countries. So Nunn and Lugar created this cooperative threat reduction program. And at that time, it sits with the Department of State and the Department of Defense. But the idea was to work cooperatively with these countries to reduce the threat of infectious diseases. And so they did that. They destroyed thousands of nuclear weapons, chemical weapons, and biological weapons. They consolidated what they had and they secured them. And so now the program has moved from those initial years into how do we still work cooperatively with these partner countries to reduce this threat. And primarily it's through strengthening their capabilities for biosurveillance, through detecting, diagnosing, and reporting on diseases. And this has made the biggest impact on the pandemic for other countries, because now they have the diagnostic capabilities. They've been trained over many, many years. They know how to do the PCR, and they have the reagents and better laboratories that are more secured. And so to me, I think it's one of the most important international programs we have. But in that context, you get scientists together in one room, and we will always talk about scientists, right? You do any scientists from around the world on any topic, and you get them in a room together without anybody else, and things are fine. But then you have the sort of the policy on top of that, and the best example I have is just right now with Ethiopia. So it's a country that I work with, that we have projects, but they're struggling right now in a civil war that has just popped up literally in the last few months in the north, in the Tigray region. And so it's come out, that they're having mass rapes, and that there's a lot of just thousands of people potentially died just in the last few weeks there. And so Ethiopia is trying to deal themselves with their civil war. But, for the world, it's still, well, this happened, these atrocities happened in your country. And so, what are you going to do about this? And so that's where bigger global things take over, small collaborations, but they are, connected hand in hand though. Yeah, it's a great question, but it's a challenge. And I think the answer though is to include is science. Actually, there's a great, it was a program that Secretary Clinton was a big proponent of with the Department of State when she was there, was scientific diplomacy. And so she used smart diplomacy with, schools, students, exchanges between countries, all kinds of things, but science diplomacy was a big piece, and building up collaborations with money and like really supporting collaborations between countries to share data. And if it's a threat anywhere, it's a threat everywhere. And so when we think of infectious diseases, we think about other things like export control of sort of, things that may have economic, it's a different issue. It's slightly easier to think about with infectious diseases. But it's a great question.
Well, and that has obviously certainly played out, right? In the last year and a half to 2 years, we're on infectious diseases, and is a good lesson. I did not realize that we are at time because this is such a fascinating topic, and Dr. Fair, you are such a fascinating speaker. So I would like to thank everybody for attending and invite people to stick around. Bradley actually has an excellent question for starting us off in our informal discussion. So Laura it's going to take just a second. Laura's going to switch everybody over to join the panelist group. So if you stay on, you'll get switched over, and we'll continue this conversation in just a minute. But thank you so much, Lupe and Greg, for organizing this series, and Dr. Fair for your excellent remarks.